try that again. If I give you a fraction such as 1/2, if I give you a fraction such as 1/2, I can take that fraction and I can rewrite it by multiplying it by a number, by another fraction that has the same numerator and denominator. So this means that 1/2 is equal to 2/4. Now you guys built it, manipulated it, and in your brain you should be able to see that we had 1/2, and then we took the half and we divided it into half again. Which made those quarters. Those are equivalent fractions. Now, when you talk about reducing a fraction to its simplest form, that's the same thing as when we took the fractions, such as the 2/4, and we saw what is the fewest number of pieces we can use to build that fraction. So if I took 2/4, if I took a quarter and a quarter, right? That's a really funny quarter, I apologize. If I took a quarter and a quarter, I know that I could cover it with just a half. Now, mathematically, what that means, you guys, is all you're really doing is writing an equivalent fraction. All you're doing is writing an equivalent fraction. So if I take this and I divide it by 2/2, all I did was write an equivalent fraction. But when you're talking about reducing, you guys, it's only using division. Reducing is only going to be using division. Now, there are 3 ways when you're talking about reducing fractions to its simplest form. There are 3 ways to do it. And I'm going to explain to you really quickly the 3 ways. For example, if I have 24/36, the first way is I could use divisibility rules. 2, 5, 10, 3, 9. Can I divide this by 2? Yes. By 5? No. 10? No. 2 plus 4 is 6, so it's a yes on 3, it's a no on 9. This is even, so it's a yes on 2, it's a no on 5, no on 10. It's going to be a yes on 3 and a yes on 9. So which ones were the yeses? I have 2 and I have 3, right? So let's say I take this and I divide it by 3/3. And I'm left with 8, and that's going to be 12ths.
Wow.
But now I have a new answer, so I have to check again. Can I divide each one by something? So I see that this is divisible by 2 and divisible by 2. So I can divide this by 2/2, and I could get 4/6. So nope, they're still both even, so I have to divide it by 2/2 again, and I get 2/3. So that's the first way to do it.
Whoa.
Now the second thing I could have done to reduce this fraction is I could have found these 2 numbers' greatest common factor, GCF. I'm going to ask you guys to have your pencils down. I'm not sure why people are writing or erasing. I'm not sure why people are playing with stuff. You should be faced forward. Your eyes should be focused here. Because it's exactly those people that are messing around with things. They're going to say, I don't get it later. GCF 24 equals 2 times 2 times 2 times 3. 36 equals 2 times 2 times 3 times 3. I could have broken it down to its prime factor form. 24 is 8 times 3. 8 is 2 times 2 times 2, so it's 3 times 8. 36 is 9 times 4. 4 is 2 times 2, 9 is 3 times 3. All I did is did it. I just did it in my head. I have a pair of 2's. I have a pair of 2's. I have a pair of 3's. 2 times 2 times 3. That's 4 times 3, and that's 12. That's my greatest common factor, also called the greatest common divisor. So I could have divided this by 12/12, which is 2 and 3 2/3. I came up with the same answer. Just a little bit different method.
It's easier.
Now here, if I divide it by 3, by 2, and by 2, that's 4 times 3, which is 12 anyway. Okay. Now the final way that I could have done this, 2436 is I could have done the prime factor form like this. Prime factorization again. That's all I did is prime factorization. And then instead of circling pairs, I'm going to cross pairs out. 2 on top, 2 on the bottom, I'm going to cross those out. 2 on top, 2 on the bottom, I'm going to cross those out. 3 on top, 3 on the bottom, I'm going to cross those out. What am I left with? I'm left with 2/3. Any of those three methods come to the correct answer. Do I personally care which method you use? For some of you guys, division is very simple. For some of you, division is simple. For those that struggle with division, then maybe you want to use prime factorization. Now, it doesn't make sense to use the GCF, really, because if you're going to break it down into prime factor form, why have the extra step, right? Instead of having to then find the GCF and divide, why not just cross it out, right? So really, between those two methods, using prime factorization or using division, either way works. Now, so in your notes, your topic is reducing fractions. Your topic is reducing fractions. So here is your topic, reducing fractions to simplest form. Put it in your table of contents. Always in mathematics. You don't have to ask in mathematics. The few exceptions we have, I'll tell you before we start. So reducing fractions to simplest form. You do not need to write what you see next. I'll tell you where you're going to start writing. You do not need to write this. I just want you focused up front, and I want you to read it with me.
You said 3 column notes?
3 column notes, yes. So after you've written your title, you put it in your table of contents, you've written your 3 columns, put your pencils down, put your eyes up front. Let's see what table is ready. And you're not writing this down. You're just reading it. Every answer. Ready? Read. Every answer, when dealing with fractions, has to be written in its simplest form. If I'm doing addition of fractions, subtraction, multiplication, division, I have to state my answer in simplest form. So that means if I come to a solution and I write my answer as 4/12 and I circle it as my answer, you will get that answer incorrect. It'll be wrong. Because 4/12 is not in simplest form. There are quick and easy ways to see if a number is in simplest form. First of all, if both numbers are even, I automatically know it's not in simplest form. When I look at 4/12, 4 is even, 12 is even, so I know it's divisible by 2. I can divide both by 2. So if I wrote 2 times 2 and I wrote 2 times 2 times 3, I cross that out, I'm left with 1/3. If I circle 1/3, then I know that I have the correct answer because 1 is neither prime nor composite, so they share no common factor. All I did was take 4/12 and I divided it by 4/4 to get 1/3. I wrote an equivalent fraction. 4/12 and 1/3 are the same value, but when you are dealing with fractions, you want the answer stated in its simplest form. If there's a way to write it with fewer number of pieces, you have to do that. Does everybody understand? Okay, ready? Read.
To take an answer in simplest form, the fraction must be reduced.
All reducing is, you guys, is taking a fraction and rewriting it, writing in an equivalent fraction. Now, yesterday when we had the number tiles and I told you to build 2/4, and I said, is there a way to make 2/4 using a fewer number of tiles? And you guys took one of the halves and covered it and said, oh yeah, there's 1/2. When we had 3/4, right? Or we had, I'm sorry, we had 9/12. You guys covered it with 3/4 pieces, so that would be its simplest form. So, because instead of using 9 pieces, we use 3 pieces. That's all it is. That's all reducing is. Okay, now this one's important, so everybody pay attention as you read this last one, please. Ready? Read. Other than 1. Now that's important because 1 is a factor of every single number, correct? But when you talk about simplest form, so let's look at the number 3/4 for just a second. If I look at what common factor do both of these numbers have? 3 is 1 times 3. 4 could be 1 times 4 and 2 times 2. There's only one common factor here, and it is the number 1. So if you are talking about simplest form and you're talking about factors, a fraction that is listed in simplest form, the only common factor they will have is the number 1. If they have a different common factor, that means I didn't break it down enough. Does everyone understand? Okay, so now you're going to start taking your notes. So here we go. Write steps. Now this is the way I'm going to teach it. This is the way we're going to practice it. However, when it comes time to doing your work, if you have a different way that you like better, that's fine with me as long as you get the answer correct 100% of the time. The problem with using division, like the first way I showed you, is most of the time kids don't break the number down enough. Okay? Because if you stop too soon, your answer's wrong. So that's why I teach it this way, because it's the easiest way to get the answer correct 100% of the time. So step number 1. The first step is you're going to rewrite the numerator and the denominator as a product of prime factors. At this point in time, most of you are getting really good at writing numbers in prime factor form. As a matter of fact, I bet you most of you are starting to see the patterns, and you're able to do some of the numbers in your brain already without even having to write anything, which is what good mathematicians do. They look for patterns. So if I take 6/8 and I take the number 6, I'm going to write 6 as 2 times 3. Now 2 is prime and 3 is prime. I'm going to take 8, and we've memorized by now that 8 is 2 times 2 times 2. Now, if you can do this in your brain, all I got to do is write it. But then, so I take my 6/8 and I write equals, and I put the prime factor form. 6 equals 2 times 3. 8 equals 2 times 2 times 2. So I have, the first step is very easy. Just take the numbers, the numerator, the denominator, and write it as a product of prime factors. Step number 2. Cross-cancel numbers that are the same in the numerator and the denominator. And it has to be a 1-to-1 correspondence, which means it has to appear on the top and the bottom, but I can only cross out one pair at a time. So when you look at 6 equals 2 times 3 and 8 equals 2 times 2 times 2, there is one 2 on top and there's another 2 on the bottom, so I'm going to cross those out. I'm going to get rid of them. And I'll explain to you in a minute what it means to cross them out. I'll explain to that what it really means in just a minute. Now, when I cross them out, I'm left with a 3 on top and a 2 times 2 on the bottom. So if I have a 3 on top, do I have any 3s on the bottom? No, I do not. I have a 2 on the bottom. Do I have any more 2s on top? No, I don't. So I can't cross anything else out. Now, the most common mistake students will make is they'll see a 2 and a 2 on the bottom, and so they'll cross those out because they say, oh, there's 2 2s there. But it has to appear on the top and the bottom. If they're on the same level, I cannot cross them out. And again, I'll explain why in just a minute. So step number 2 is simple. You just look for numbers that are on the top and the bottom, and then cross them out. It's like you're getting rid of them. Okay. Step number 3. It says multiply the remaining numbers in the numerator. When I cross out the 2, the only thing I have left in the numerator is just a 3. So there's really no numbers to multiply there. So 6/8, I cross out the 2 on top and the 2 on the bottom, so I'm left with 3 on the top. So my numerator in this case is a 3. I bet you could guess what the next step would be. The next step would be to multiply the remaining numbers in the denominator. Now in the denominator, I had 2 times 2, so I just multiply. 2 times 2 is 4. And now my fraction is written in its simplest form. The answer is 3/4. So 6/8 is reduced to 3/4. I'm going to give people just a couple more seconds on number 2, because I'm sure people are still writing number 2. Now I'm going to pause the recording. Is absolutely vital to understand what I just showed you, why it works. So everybody pay very particular attention. If I show you this, 4 divided by 2, okay, it's a very simple division problem, right? So I can take 4, I can write it this way, 4 divided by 2. I could look at it this way, but either way, the answer is the same, right? When I'm looking at division, it means 2 times 2 equals 4, or 2 times 2 is 4, I subtract, and I have 0 left over. Okay? It's just simple division. Another way that I could write this is like this. What did I turn my division problem into?
An improper
Fraction. All a fraction bar means, you guys, is divided by. 4 divided by 2 is all a fraction bar means. So when I take 4 divided by 2, I know that that answer is 2, right? But I'm going to take these two numbers and I'm going to multiply them to equal that number in this case, correct? Does everyone understand what I just did? So when I look at a fraction or a fraction bar, it just is another way to write division. So if I give you this, everybody watch what I'm about to do. I can take this and extend it and bring it down, and I can drop the 1 inside. I just now have a regular division problem, right?
2 divided by 1.
But 2 won't go into 1, so I'm going to put a decimal point in a 0. I'm going to bring that decimal point straight up. Now 2 will go into 10 5 times. That's 10. That's 0 left over. So 1/2 is 0.5 or 5/10.
Wow.
So if 1/2 equals 0.5, what is 0.5 times 2?
10. 1?
0.5 is 1, right? Does everyone see what I just did?
Didn't you just say 2 is awkward? Get it.
0.5 times 2. So if I take 0.5 times 2, that's 10. I move my decimal place 1. I have 1.0, right?
Wow.
Right?
Yeah. Oh, so we're matching up the decimal?
When you multiply with decimals, you always have to put the decimal place
Mr.
over,
Pepper?
right? Now, here is why cross cancellation works. If I give you 6/8 and I said 6 is 2 times 3 and 8 is 2 times 2 times 2, I've rewritten this in this fashion. But let's look at what this truly means. This means 2 divided by 2. What is 2 divided by 2?
1.
So that crosses out, but it's not like it really just goes away in a puff of smoke. I'm really doing the division. 2 divided by 2 is 1. Do I have a 3 divided by 3 anywhere? No. So now when it says multiply the remaining numbers, what is 1 times 3?
3.
And then what is 1 times 2 times 2?
4.
All I'm doing when I cross cancel, you guys, is I'm doing the division first. That's it. Does everyone understand what I just did?
Yes.
Question?
It's like dividing 2, it's like dividing 6, 8 by 2.
You're right. So let's look at this one. Let's look at 12 sixteenths. Now 12 is 2 times 2 times 3. 12 is 4 times 3. 4 is 2 times 2, right? 16 is 4 times 4, and 4 is 2 times 2. So this is 2 times 2 times 2 times 2. What's 2 divided by 2?
4.
2 divided by 2?
1.
Cross it out, I have 1 left over. What's 2 divided by 2?
1.
1 left over. I have a 3. Do I have a divided by 3?
No.
So 1 times 1 times 3 is just 3. 1 times 1 times 2 times 2 is 4, correct? This is why, you guys, cross-canceling works, is because I'm doing the division before I'm doing the multiplication. I'm dividing first. Question? Mm-hmm. Okay, if I'm doing prime factorization, I could have said 6 times 2, right? But 2 is prime, but I have to break 6 down into 2 times 3. I just did the prime factorization in my brain. I know that 4 times 3 is 12, so I wrote the 3, and then in my brain I said, what's 4? It's 2 times 2. That's all I did. So I can only write prime factors here. That's a great question. I can only write prime factors here if I'm going to use this method. Okay? Yes?
If you don't cross cancel, it will be harder.
If you don't cross cancel, then if I did cross cancel, I'd come up with 12 sixteenths again, right? Nothing would change. So I have to cross cancel to reduce.
You have
Yes. Well, again, I can go back to what I originally showed you, right? I could show you that originally I could use division until I can divide no more. I could use the GCF, or I could use prime factorization. To me personally, this is the easiest. Prime factorization is the easiest because this way it's too easy to make a mistake until you really know numbers. Until you really get the way the number system works. And usually this comes about 8th or 9th grade. You start getting the pattern so well that you don't need to do prime factorization. But until then, to guarantee that you don't make mistakes, that's why I say use this way. So you don't make simple mistakes. Because what kids will do is they'll say, oh, I see I can divide this by 3 and I can divide it by 2, and then they'll stop here, let's say, not realizing. And it's really when one number's, like let's say this was a 3 and this was, a 12. And then they'll stop not knowing that you take 12 and divide it by 3.
Yeah.
Okay. Does everyone understand?
Yes.
Or what happens if you have a number that's weird, it's not divisible by 2, 3, 5, but they're both divisible by 11 or something. Pattern, right?
Yes.
So, whiteboards, markers, erasers out. Let's practice. Go.
Can I buy one for you right now? How much is it? $1? I know, it's in my backpack.